Hello everyone! Welcome to another session in our civil engineering refresher and review. And for this video, we will continue with our topics on dynamics and physics. And for this video, our featured topics are rotation and friction. Rotation, or we call it a rotational motion, also known as rotatory motion, is a type of motion in which all points of a rigid body maintain a constant distance from an imaginary axis, which we call the center, and rotate in circular paths about a common axis with a common velocity. So, if you recall, we have the linear parameters na. So, in linear, we represent the distance traveled by S, the velocity by V, and the acceleration as A. Now, in rotation, the distance traveled is expressed as angular distance, and the measurement there, the unit, is in radian. The velocity is in terms of the angular velocity, rotational velocity, and that is expressed in the unit radians per second. And also, if the rotation is accelerated, so we have the alpha to represent the angular acceleration, expressed in radians per second square. Okay. So, we have now a rotational motion. So, let us say this is point 1 and then this is point 2. So, let us say the body or any point on the path travels from point 1 up to point 2 here in the figure. Okay? So, if the point is at a distance r from the axis, so the axis is the center of the circular path, So, the distance traveled is expressed in terms of the angular measurement, and it is equivalent to the linear distance as here. Then, the angular velocity is expressed in terms of radians per second, represented by omega, and that is the equivalent of the linear velocity v in linear motion. Also, if this is accelerated, so alpha to represent the angular acceleration, so equivalent to alpha in the linear acceleration. So we have there the relationship, so how to change rotational to linear values. So, if we are given theta, omega, and alpha in rotational motion, then how will we convert it to the equivalent linear motion values? So, simply, we have S equal to R times angle theta, V equal to R times angular velocity omega, and A equal to R times the angular acceleration alpha. So, R here is the distance of the circular path, or that is the distance of the point considered to the center. So, we have the R. So, notice that in order, as we go through the formulas here, we can say that in order to change rotational values to equivalent linear values, multiply the rotational values by the radius r. So, the distance of the point considered from the center to the circular path. And the resulting values there are the equivalent linear values. Okay, so we have also two types considered here of motion. One is with constant angular velocity. So, if we have constant angular velocity, so if this is point 1, and this is point 2, no? So the velocity here is constant, and that is omega, expressed in radians per second. Then we have the angle turned through, the angular distance, theta, and then we have the distance r of the point considered from the center of the circular path. So our formula is theta equal to omega times t. So take note, this is the same as our formula in linear, na? Same as S equal to V times T. Na? So distance equal to velocity times time. But here, we are using the angular parameters. Na? So we have theta equal to omega times the T. So problem, sample we have here. A flywheel is turning at a constant rate of 150 RPM. How long will it take for the flywheel to turn 1,400 pi radians? Okay, so we have here a flywheel, na? So this is rotating, na, at a constant rate of omega. Equal to 150 RPM. RPM is revolutions per minute. And then the angle turned through is 1,400 pi within the elapsed time. And that is the question. How long will it take for the flywheel to turn 1,400 pi? So we can use this formula, na? Theta equal to omega times t. But we will first convert the revolutions per minute to radians per second. So multiply 1 revolutions equal to 2 pi radian, and 1 minute equal to 60 seconds. So revolutions cancels out, minute cancels out, and the resulting unit here is in radians per second. So that is 5 pi radians per second. So using now the formula, theta equal to angular velocity times time. So theta is 1,400 pi equal to 5 pi times t. So t is equal to 280 seconds. Okay, so let us have another example. What is the linear speed of a point on the edge of a 16-inch diameter disc turning at 50 RPM? So we have a linear speed. So what is the linear speed? So meaning we are asked to solve for the velocity, linear velocity of a point on the edge of a 16-inch diameter disc turning at 50 RPM. So the angular velocity is 50 revolutions per minute. We can convert this to radians per second. So 5.236. And then at a point which is on the edge of a 16-inch diameter disc, what is the linear speed? So linear speed equal to r times omega. So the diameter is 16, so the radius is 8 inches. We divide it by 12 in order to have feet for our unit. Then this is 5.236 radians per second. So the answer is 3.49 feet per second. Okay. By the way, the unit radians per second, the unit radian is an amount of rotation. So meaning, as if there is no unit there now. So 5.236 per second. So that is why when you multiply it by 8 over 12 feet, so the resulting unit is feet per second. The second case is when we have a rotation with constant angular acceleration. So if the rotation is accelerated, meaning it has changed in velocities. Okay. So let us say this is point 1. So this is point 1 here, the starting point, with angular speed omega 1. Then this turn in a rotatory motion or circular motion and reach point 2 here, na? Reach point 2. So it has traveled an angular distance theta, and then since this has an acceleration alpha, so the final velocity omega at point 2. So there is a final velocity omega at point 2. So what are the formulas that can be applied? So again, we have the same formula for our linear motion, but take note, we will just change notation. So theta for S, omega for V, and alpha for A. So we have here our formulas. So observe, this is equivalent to V equal to V1 plus minus 80. This is equivalent to final velocity square equal to initial square plus minus 2AS. So this becomes 2 alpha acceleration. The angular distance is theta. Then we have also the third one. Okay, so let's apply where we have here the notations. We know this already. A motor takes 10 seconds to go from 180 radians per second to 50 radians per second at constant angular acceleration. Compute the number of revolutions it makes during this time. Okay, so we have initial velocity 180, final velocity 50 for a given time of 10 seconds. So observe that the rotation here is decelerating, So the final velocity is lesser than the initial velocity. So we can first compute the acceleration, So final velocity equal to initial minus alpha times t. So this is 80, this is 50, this is 180, then the time is 10. So we can solve for alpha equal to 13 radians per second. Then we can use the third formula, So the number of revolutions it makes, so that is the angle theta. So initial velocity times time minus 0.5, acceleration times time square. Substituting values, we can get theta. So this is 1,150 rad. But we are asked for the number of revolutions. So we simply convert 1 revolution equal to 2 pi rad. So rad cancels out. The resulting unit here is in revolutions. 183.03. Okay, so that is about rotation, so motion in a circular path, We have here friction. So friction is the resistance force that an object encounters when moving over a surface. So this friction force is parallel to the surface in contact. And this is opposite in direction to the motion or the possible motion of the body. So we have two kinds of friction. One is static friction, that is when the body remains at rest. And then we have dynamic friction when the body is moving. So let us say we have here a body resting on a surface. So we have the weight W here. And how about the normal force N? Okay. So this is in equilibrium, so meaning no motion. How about if I will apply a force P to the right? So the tendency is that the block will move to the right. So it may move, so there is motion, or it may not. So motion is there is motion or we have the possible motion. So when you say possible motion, that is, the body is not moving, pero there is a possibility for it to move in the right direction. Huh? Okay. So, we have now the opposing friction force. And since the motion or the possible motion of the block is to the right, so friction is acting opposite. So, we have here the friction force F. So, the resultant of F and N is the resultant force R, and this is acting at an angle of phi with respect to the vertical. So, in this case, we have the friction, the normal, the resultant, and then the coefficient of friction, and then the angle of friction. So, what is the coefficient of friction? So, the coefficient of friction is related to the angle of friction. And they are related by this formula, na? So, the coefficient of friction is equal to tangent of the angle of friction. So, mu equal to tangent of phi. Then, in the figure, as you can see, we have here also our F, and we can write tangent of the angle of friction phi, that is equal to F over N. That is F over N. But notice, our tangent of phi, is equal to the coefficient of friction mu. So, in that case, or in that formula, we can solve for F, and F is equal to coefficient of friction times N. So, we will be using these two formulas in solving problems. Okay. Now, this F equal to mu times N is what we call the limit friction. So, the limit friction is the maximum value of the friction force. So, that is when you multiply the coefficient of friction and the normal force. So, it is like this, Example, if we have our weight equal to 100 newtons, and our coefficient of static friction, I have here place a subscript S, meaning static friction. So, weight is 100, the friction coefficient is 0.3. So, our N, so in the figure, if this is 100, our N is also equal to 100. So, if you compute our friction, so the limit friction, the maximum value of the friction is 0.3 times 100, or that is 30. Why I said this is the limit or the maximum value of the friction? Because this may or may not act fully on the body. So, say for example, if my P is 10, if this is 100, this is 100, this is 30. If my P is 10, our F is not 30. That is only 10. Can you imagine? This is 10, this is only 10. And the block is at rest. Can you follow? So, the maximum value or the limit friction, which is 30, will not act fully in this example if our P is 10. So, F is only 10, not 30. And the block is still in equilibrium, at rest, not moving. How about if P is 20? So, if P is 20, F is also 20, not 30. And the block is still at rest. How about if P is 30? So, if P is 30, F is equal to 30. And the block is still not moving, but this is about to move. Or shall we say, motion is to impend. Then, how about if your P is greater than 30? So, if P is greater than 30, let us say 31, 32, and so on, your F is at maximum, that is 30, and the block will move to the right. In this case, since there is already motion, the static friction will change to dynamic friction with other conditions given. Let us say in the coefficient of friction, if we have different coefficient of friction, usually the coefficient of dynamic friction or kinetic friction is lesser compared to the static friction. So we will have more examples on this of moving body with friction when we have additional examples in Newton's second law of motion. Okay, so as of now, in the succeeding examples, we will just have static friction acting, so meaning the body is not moving. Or in my third example here, although there is motion, but the motion is with constant velocity. We will elaborate that later as we go through the examples. Example, we have here problem number 4. A block weighing 350 pounds rests on a plane inclined 30 degrees with the horizontal. The angle of static friction between the block and the plane is 15 degrees. So this is angle phi, angle of friction. Number 1 question, what force P parallel to the inclined necessary to hold the block from sliding down the plane? Okay, and then I will solve first number 1 before I will read and answer number 2. Okay, so we have here the block resting on a plane inclined at an angle of 30 degrees. So what are the forces acting? We have the weight equal to 350 pounds. And then the weight can be resolved into normal, perpendicular to the surface, and parallel or along the surface. So if this is angle 30, this is also angle 30 here. Can you follow? So the normal force, normal component of the weight, when you say normal, that is perpendicular, So normal or perpendicular to the surface. So this is 350 cosine of 30, so 350 cosine of 30, so this is 303.11. And the component of the weight parallel to the inclined is 350 sine of 30, that is 175. So the possibility here is that the block will slide down the incline, so meaning our friction is in opposite direction to the possible motion, then we have also our P. We are asked for P. What is the value of P parallel to the incline necessary to hold the block from sliding? So if you place a force P to hold the block from sliding, so we have the normal also equal to 303.11, and we have our friction force F. So the friction force is directed upward because without P, this will tend to move down. So without P, the block will slide down due to this component of the weight. So the friction will resist. And since the friction, if you try to check, later, the friction is lesser than 175. So that is why we need a force P to hold the block from sliding down. Okay, so nakuha niyo yung situation dito. So we can solve for our F. By the way, we are given the angle of friction, so we can solve for the coefficient. So mu equal to tangent of 15, so that is 0.268. Then our F is mu times n, so we can solve for our F. So notice F is 81.23, and then our component of the weight along the incline is 175. So this is greater compared to the friction. So the tendency is that the block will slide down. And then we need a force P to hold it. So in the figure, if I will call the inclined as the x prime axis, I can sum up forces along the x prime. So upward is P, upward is F, and then we have downward, inclined downward, 175. But F is 81.23, so we can solve for P, that is 93.77 pounds. Okay, how about number 2? What force P parallel to the incline necessary to cause impending motion up the plane? So, the difference between question 1 and 2 is that in number 1, the P is only to hold it from sliding down. But the question for number 2, we will apply a force P so that this will tend to move up. Na? So, to cause impending motion up the plane. So that is when you apply the force P, this block will start to move upward along the incline. Okay, so in the figure, we have the same figure. The only difference is the direction of the friction. Because when you apply the force P, this will start to move up. So our friction is to oppose the motion. And this is now directed downward, opposite to the possible motion. So, we have the same value, 175. We have the same value for the friction. This is 81.23, I think. And then we are asked for the P. So, summation of forces along the x prime axis. So, P is equal to 175 plus F. But F is 81.23, so the P is 256.23 pounds. Next problem. An 8-meter long ladder rests against a frictionless wall with the foot of the ladder inclined 53 degrees from the floor. The center of gravity of the ladder is 3 meters from the foot of the ladder. If the ladder weighs 200 newtons, find the coefficient of friction between the foot of the ladder and the floor. Okay, so solution, we have to draw the figure na. So we have an 8-meter long ladder rest against a frictionless wall, and the foot of the ladder inclined 53 degrees from the floor. So the center of gravity of the floor is 3 meters from the foot. So from the foot of the ladder, 3 meters, we have the weight 200 newtons. Okay. So I will call this point 1. This is point 2. So when you say frictionless, this means no friction. So at point 2, since there is no friction at point 2, so we have only one reaction here, and that is the normal reaction R. At point 1, so this is with friction, we have the normal N, and due to the weight, this will tend to slide along the floor. So we have the friction directed opposite to the motion or the possible motion. Okay. So I will call this distance Y. So in the figure, the ladder is inclined 53 degrees and then the length is 8. So this is 8 sine 53. 8 sine 53, so that is 6.39. So the horizontal projection of the weight along the horizontal, I will call it X. And X is 3 cosine 53. That is 1.805 meters. Okay. So, I can now apply our static equations because this is in equilibrium So, I can sum up moments about point 1 in order to solve for R. So, R times Y, or that is R times 6.39, equal to 200 times X. So R times 6.39 minus 200 times 1.85 equal to 0. So R is 56.49 newtons. Then I can sum up forces horizontal and vertical. So by vertical forces, my N is equal to 200. By horizontal forces, my F is equal to R, 56.49. Then what is the question? Coefficient of friction between the foot of the ladder and the floor. So I have F equal to coefficient of friction times the normal. With the normal and the friction given, the only unknown here is the coefficient of friction. That is 0.28. Okay lang ba? Kumusta? Kuha lang, no? Simple lang yung mga problems natin. Okay, so I think this will be the last problem, na? A 1,000-pound sled is pulled along a horizontal surface at uniform speed by means of rope that makes an angle of 30 degrees above the horizontal. If the tension in the rope is 120 pounds, what is the coefficient of friction? Okay, as you notice, our sled here is moving. Pero this is moving with uniform speed. And if the body is moving with uniform speed, there is no acceleration, we can apply directly our static equations in solving. But in the next topic here, in which we have the motion of a body with acceleration, so if the body is moving with acceleration, then that is acted by an unbalanced force. So there is a resultant force on the forces acting of the body. So that is not balanced. That is why the body is moving with acceleration. So that is our next topic. That is Newton's second law and the Lambert's principle. We have the reverse effective force. Okay. So again, although this is moving, but moving with uniform speed, we can directly apply our static equations. So this is the sled. This is pulled by a rope now with a tension of 120 pounds at an angle of 30 degrees. Then we have the weight here, 1,000 pounds. So what are the forces acting? We have the normal. Okay. Then the 120 can be resolved into, we have the friction, opposite to the motion. So this is 120 cosine 30, 103.39. This is 120 sine 30, that is 60 pounds. So notice that your N is not equal to 1,000 because you have the component of the 120 pound force directed upward. So if you sum up forces along Y, N here is equal to 100 or 1,000 minus 60. Or we have N plus 60 equal to 1,000. So N here is 940 pounds. Then if you sum up forces along X, so friction is equal to this component of the force, 103.92. Then we have N and F. We need to solve for the coefficient of friction. So by the values of F and N, we can solve for the coefficient equal to 0.11. Okay, so we have two topics here. So the first is rotation, and the second one is about friction. So thank you very much for joining with me in this video, for joining or for viewing my video, and I hope my video discussion contributed to improve your knowledge in the topic and help you solve your quiz, your practice problems or possible in the exam. Till next time for the next video.